Hello, so I just wanted to say a few words before playing this video. This is a very interesting repair. It's not for everybody, so it's for the people that are really interested in repairs and the diagnostic process. This will be a repair for a laptop that actually doesn't worth the value of this repair, but it's a very good starting point for people that are interested in the diagnostic process and how things work in a laptop, right? I know that many say that they can't stand my voice or that I'm a bit slow, so this is gonna be a slow video because it's mostly unedited. And I hope you really enjoy it and save your time for this one and watch it closely because it's extremely interesting. Hello. So today we're working on an Acer Aspire 3 15 inch. This is that, but it makes no sense to try anything because I already received it in this status. I understand it has been there was some shampoo leaking. The board looks really bad. Yeah, I don't know what. Let's try to do some measurements. So I'm gonna put the multimeter in continuity. I'm not gonna connect it to the power just yet. I just want to figure out what is going on here. I'm trying to see if we have some sort of a main power rail, and I think the main power rail is on these caps. They are on 25 volt. Yeah, and I don't have any short on those. Yeah, I think this should be the ground, correct? So let's do some coils. This is fine, there's no short. Yeah, this is 4 ohms, 4 ohms, 4 ohms, 8 ohms. So I think this is the chipset and those are the power rails. I have nothing on this coil, and on this one I have 800 ohms, and there's another coil right here, 230 ohms. But for the rest I can't see anything. I think this is really bad. So this part here, I think this is the driver for the rails of the CPU, and I also see very corroded legs for the ENE chip, the EC chip. So I think the best plan is to actually remove this and move under the microscope and see if we can save something of it. Yeah, and we can see a big mess around here. I don't know what is here. So somebody definitely has worked on this heavily. Yeah, we can see solder right there. Oh, Jesus Christ. This is really nasty. I don't know. I really don't understand who works on this. Did I break my tweezers? Yeah, this leg is not there. Oh, this looks really bad. Let's see if we can clean it with IPA. I don't know what was it here. They said the service repair shop that this comes from said that it was actually shampoo that was dropped on this thingy. Maybe it was in a in a bag and the shampoo got spilled. Otherwise I can't really understand how could shampoo get on your laptop. Yeah, these are really bad. Really bad. Let's see if we can fix it somehow. Gonna add a bunch of flux. Let's see the temps. Let's see if we can do something with a small knife tip. Maybe we are lucky, or maybe not. Yeah, I don't care about bridges right now. What I care is for solder to stick on both the pads and the legs. Of this CC chip. And like this we can remove the actual bridges. Yeah, what can we say? Maybe we're gonna test a bit later. Let's fix this side here, because these two pins are also very corroded. I think that's a ground plane right here. Let me add some heat. Yeah, I don't know. I don't really know what to say. And we also have some gunk over here. No, but I think that is good. I don't know. I am a bit reluctant about this. I don't like what I see here. So in between these legs here, there's a lot of soot. Not sure how to clean that, maybe with a finer brush. Yeah, not good. Let's see. With a knife tip maybe. We can break that loose. believe here the best would have been ultrasonic clean, which I don't have. Yeah, but they look better now. So first, let's test the continuity. We're still in continuity mode. So I'm gonna test these tracks here. For example, this one is good. Yeah, this one has continuity. There's no short between the legs. Here, no short. Here, no short. No short. Good. Now let's see some others. This is good. This is good. 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 What about this one here? Good. Okay, so now let's see if we have any sort of shorts on the power lines on this CC chip. So I need to find the proper ground, like here. So here we have no short. That's a ground. This is a plus. So there's no short there either. Yeah, and I don't have other caps around here. Yeah, I have something here. So why this one? This one is low. 0 ohms. Okay, so this is a plus. We have a cap here. I don't know what this is. That's weird. Right? It is weird. Let's measure here near the BQ chip. Yeah, these are fine. No short. No short. Yeah, and no short here. I'm gonna clean up this area a bit because it looks a bit funky. I don't understand exactly what's happening with this one because I didn't power it on yet. I usually don't when there's liquid damage. I tend to do a visual inspection and clean. Yeah, so I don't know why they put this Captain tape here. Maybe they messed up the connector. Yeah, so we're gonna move further on this board. Yeah, I don't like this clock chip here either. This is a clock chip that is not properly cleaned around. The CPU bracket is missing a screw there. I don't like what I see here, so let me remove this CPU heat pipe. Yeah, because I wanna have a better view on what is going on here. So let me clean this crap. Let's clean the paste the best we can. Yeah, so it's just thermal paste, that's not a big problem on those caps. Excuse me. Okay, so let's continue our cleaning. I'm gonna go right here. Yeah, seems to be cleaning quite well. I don't see much damage over there. Yeah, there is some damage here. Maybe take the softer brush. Yeah, looks good. There's a bit of trouble here also. But it's not looking that bad, to be honest. I don't like the fact that somebody worked on it already. There's also something here. And this is the input circuit. I see the CPU is an AMD Ryzen 7. So as you noticed, I didn't notice any obvious shorts, and besides those EC chip pins that do not appear to make contact anymore, so I have here this that appears to be replaced or something. Somebody was tinkering with it. Yeah, I don't like the fact that this area has been worked on. I don't know what they replaced there. Well, they put a solder blob. Right here, see? I don't know what this chip is, but it might be the driver of the CPU phases. So let's look on the other side. Yeah, we can do some maintenance here too. It's not bad, or it's not that bad as it was on the other side. This is looking well. This we can give it a wash, a clean. Good. Ah, this is bad here. Okay, so let's see if any of these caps are actually shorted. Yeah, we have a short here, or maybe this cap is parallel to a no short here. So what is this? Can it be the cap is maybe parallel? Yeah, there's no ground, so this might be a current sense circuit, and this cap might be parallel to a current sense resistor. Let me see if I can figure out where it comes out. But I can't really tell. So all those damaged parts are below this driver, which I think it's a driver. I can only think that maybe it's an audio IC. That would be funny. That would be really funny. Okay, so let's try. Let's try to reflow this, well, not reflow, but replace the solder here. Because there was a lot of gunk between these pads, and this way we're gonna clean it a bit and restore its former glory. Like that, right? Yeah, it looks way better now. Good, so where were we? We were on the back. Let's see around here below the CPU, and this seems fine. Here it's fine, fine, fine. I think we're good so far. Okay, so let's see the main line. Is it shorted? I don't think it is. I think we already measured it, right? So we should have a main right here between these caps. Yeah, no short. Good, so let's connect the power supply and see what is going on, if I can ever find it. Okay, let me start it. We can see it right there. It says 19.1 almost. And if I connect it, yeah, we have 10 milliamps almost, which is normal. Which is actually normal. So which one is the... I think this is the keyboard connector. Let's see, do we have a 3.3 around here? I'm gonna switch the multimeter to voltage mode. I'm sorry, my voice is not very happy, but it's very late today and I had a full day working. Here we have 2.6. Here nothing. 3. 3.2. Let's see these big ones. Nothing. 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 Where's the power button for this model? I don't know. Let me check the voltages on the EC chip. So what do we have here? We have some caps that we can probe. So first on this line we have 3.3. yeah, so that's the LDO probably. Now I don't have, how to say, where the power button is. 1 second, let me have a look. So power button is on the keyboard, right, and I don't know which of these could be the 3.3, so I think I'm gonna put the board back in the chassis. Let's do that. Okay, so let's see what's going on. Where is my pin? It's right here. So if I connect the supply, we have 10 milliamps. The BIOS battery is disconnected. I'm gonna keep my hand on the CPU and I'm gonna press the power button in 3, 2, 1. Nothing. When I press the power button, the current goes low then back high. Maybe it should beep or something because it doesn't have RAM. But I think we should actually see something without RAM. So let me connect the battery. And let's see, do we have a charging current? I think we do. So we have 256 milliamps. Let's put it in, it's in DC voltage. I lost my lead. 1.5 amps, so that's charging. That is definitely charging current. Yeah, and we can see the voltage on the battery is going up. So we have charging. That's good. I would like to very much to see it boot, but for some reason it doesn't want to. Yeah, if I press the power button, it goes to 0, like it's resetting. Why is it? Okay, let's see some voltages on the board, see if we're missing something. So here on this coil we have nothing. This coil nothing. This coil we have 5 volt. Yeah, that's the charging coil. These are the CPUs, obviously. They are gonna be blank. This is probably the, well, it's an AMD. So here I have 5 volt, and I bet this one should be 3.3, but this one is not working at all. Nothing here. And maybe this should be the memory, so no 3.3 line. Why not? Because there was no short, so I'm gonna I'm extremely tempted to give it a 3.3 on this coil if this would be the 3.3 line. I don't know, but I think it is. Yeah, I'm gonna risk it. I am going to risk it. Yeah, maybe start slow. No, I'm gonna give it the beans. There's a button here, I don't know what this button does. Okay, so if I pressed it, it has reset again. So let me measure again the voltages. Yeah, this is 5 and this is not. So let's see, I have 3.3 on the other supply. If I turn it on, yeah, I get 96 milliamps. What happens if I push this button now? I'm keeping my finger on the CPU to see if I get any sort of a hit signature. Yeah, but I get nothing. Okay, let's try the button. Having difficulties here. Holding this. Pressing the power button. This goes to 0 when I press the power button. Why? Okay, let's remove the battery because it doesn't help us. And I've plugged in only the power adapter, and let's see, we still have 5. Yeah, we still have 5. On this line nothing, on this one nothing. I would have expected at least a beep or something, but this one is not booting at all. Pressing the power button does nothing. Give me back mine 3.3. This is really interesting. It takes like 96 milliamps until I press the power. If I press the power, it takes absolutely nothing. That is freaking annoying. What do we have here? Yeah, we have the main here. Main. So probably this is the input side. Okay, let's disconnect everything and let's put the meter in. I'm gonna put it in resistance. Yeah, and see what the resistance was here. 600 ohms on the alleged 3.3, and the 5 volt is about 20, 17, 16, 14 kilo ohms. 600 ohms. Okay, let's see what's heating up. Start this one, and I'm injecting 3.3. Now I get only 7 milliamps. 20, 19, 19 milliamps is not great. Let's see if we can spot something. No. 19 milliamps. Is low anyway. Okay, let's see what's heating up. If I plug in the power, let me remove the macro lens. Yeah, and when the power is plugged in, we have this chip here, which I believe is the 3.3. See? That one is glowing. Yeah, obviously. But why? I think this is also producing an LDO voltage for something. Okay, let me remove this so we can see better what else is getting warm. No, there's nothing really except that particular chip now is pulsing, like it's trying to start and it's failing. See? Okay, let me inject back and see if I inject, does it heat up? It doesn't. Yes, so I still get 10 next day into this. I found, with the help of my laptop fix friend, I found the schematic for this one. So my problem is with this circuit here that I believe it's the 3v3 line, right? So apparently this is PU301. So if we go to the schematic, how do I search here? Control F, PU301, 301. Next, now this one. Yeah, so this is what I need, PU301. How do I scroll this? How do I... PU301. Yeah, so it's clear this is producing the 3V always present, right? And we see also that it has here a disconnect pad, right? It's a PJ302, and my idea is to test if this chip works, because I can't find any short or none of the pads, right? The line is not shorted here on the output. We have no short here, and we have no short on the input. And I can also see this kind of like blinking, thermal speaking, right? But that's it. So my idea is to disconnect this. So we disconnect this line from the system, and I'm gonna power on the chip using 19 volt on its input, and I'm gonna provide an enable signal on pin 8. Probably this is the one, I don't know, it has 3V enable, maybe on pin 9. Yeah, we're gonna test, and we're gonna see if it produces this voltage. If not, I'm gonna have to find this chip, but it's very difficult to find. I can find it only on AliExpress, right? So here is the PG302 that I'm gonna disconnect actually. So we have this supply disconnected from the system. It might be also a problem from the EC chip, because I think the EC is providing the enable signals for these 3 and 5V lines. Yeah, but until we get there, I'm gonna disconnect this one. I'm just putting some lower melt so I can actually wick it. I can't find anything that I need. Yeah, so we actually have the line disconnected now. I'm gonna add a wire here, and probably I'm gonna use the oscilloscope to visualize if we have any output and how clean the output is. Let's see if I can solder this tiny wire here. Is it this? I don't have enough solder, and because I'm too lazy to actually stretch and get my solder to add some. Yeah, so this is the output, right? And I'm gonna solder another wire for the input, and let's see where the input is. So input is pin 234, 234. If we go back to the microscope, pin 1 is here. So pin 1, 2, 3, 4. So this is through this inductor. We should have the main rail. Yeah, let's add some solder here too, so that we won't have the same issues we had previously. Good. And I'm gonna solder another wire here on the input. Perfect. Perfect. So now let me get the supply, the 19 volt. I'm gonna connect it here. The plus should be here. Yeah, I need a ground. Where can I grab a ground with this short wire? Maybe here. Okay, and let me connect the output to the oscilloscope probe. Okay, like that. And I'm gonna connect the ground on one USB. Okay, let me bring you the oscilloscope on screen so you can see it. Right there, I'm gonna turn on the 19 volt supply. It is on. Let me bring also the instruments on the screen. Perfect. Okay, so we have the 19 volts in, we have a 9 milliamp consumption, but we knew already that. Let me first check if we really have the 19 volts getting here, right? So how can we do this? Because I need to arrange them somehow so you can also see, because you can't see nothing because of the oscilloscope screen. Yeah, so here we should have 19, right? and we don't. We don't because I lost my ground. Let me try to use a USB connector for this one, for this ground too. Good. Now we have 19 volts on the input, we have nothing on the output as we can see on the oscilloscope. Good. I think this other one should be on. But it's not, but I don't care. Okay, let's look on our thingy. Now we have 19 volts. Let's see. So this chip is also outputting an LDO, which is on pin 13, right? So on pin 13 we should have like an LDO. I'm not sure if it needs an enable for that, but maybe it needs. So we said pin 13. Pin 13 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. So it can't be that one. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13. So here we should have 3v3 and we have the LDO. Look there, right? It's outputting the LDO. It's outputting nothing. Yeah, so we have 3v3 LDO. And now we should come with a supply. I don't know what's the voltage to enable it. I'm gonna try 1.8. I have the second supply right there. Yeah, and I'm gonna try to come with the second supply on the enable pin. See, so I'm trying to investigate if this chip is actually good because I don't have one to replace it. So which was the enable? I forgot. So enable pin is either 8 or 9, probably 9. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should be enable. So I'm inputting 1.8 volt. Yeah, but it's getting, let me short with the ground. No, I lost my ground. Okay, let's try again. Now if I short with ground, yeah, the supply is taking 2 amps. Okay, let's do it now. And the 3v3 is up, you see there on the oscilloscope. The DVM shows the voltage. If I remove the enable, it goes out. If I turn on the enable, the chip works. Yeah, so we have absolutely no problem. Good. Now let me connect it back to the circuit, and I'm curious if it's connected to the circuit. I'm curious. I'm gonna disconnect the probe from the oscilloscope for a second because I don't trust this solder iron, and I'm not sure what is outputting. I don't want it to go to my oscilloscope. Good, so now we have the circuit connected. We have 19 volts. Yeah, let's try to enable it and see if it keeps the line up. So now if I go back here and enable it, yeah, I have 3v3. 3v3 works. This is highly interesting. So why it's not enabling it like it should when working? Okay, let me disconnect everything. I'm gonna turn off the supplies. Yeah, I'm gonna remove this 19 volt rail well, wire from here, and I'm curious to see where the enable pin goes. It's a bit difficult to figure it out on let me turn off the oscilloscope. It's a bit difficult to figure it out on the schematic, but I'm gonna actually get this wire from the 3v3 line, yeah, and I'm gonna try to solder it here on the enable pin. Easier said than done. Okay, and now, because of my OCD, I need to remove this excess solder here. Drop my soldering iron. Good. So I need this line. I'm gonna connect it again to the oscilloscope because I wanna see, well, obviously it's not gonna get any kind of result, but first let's see if it's coming directly from the EC chip. So that's my curiosity. I'm gonna put the meter in continuity, yeah, and now it's in beeping mode. So this wire, I'm gonna connect one of the probes, yeah, check it here. Yeah, so it's connecting there, and I want to see if it comes directly to the EC chip. So I'm just gonna go like this on all the pads. I'm not sure exactly, as I told you, what is producing it. Yeah, but it doesn't seem to come directly here. And that's weird. So I don't know what enables it, but fine, no problem. I'm gonna leave this connected to the oscilloscope, the enable line. Okay, and let me get the power directly to the motherboard. So I'm gonna connect the power to the power connector. I want to come right here. Good. This is on. Turn the supply on. We should have about 10 milliamps. Yeah, 9. Okay, let's put the multimeter in DC voltage. And let's measure the lines. So I have 5 volts here on the 5 volt coil. Yeah, but I have nothing on the 3v3 because I don't have the enable pin. Let's see how the 5 volt is being enabled. Maybe we can figure that out. So the 5 volt, we have it here, 5 volt, and the enable is pin 12, right? Pin 12, let's remember that. And let's see on this chip, pin 12 is, this is pin 1, 1, 2, 3, 4, 5, 10, 11, 12. So this is the enable. Enable is 3.3. 3.3. Let's see, do we have the 3.3 LDO here? No, because when we tested, we had it. So now there is no 3v3 LDO. That's interesting. Why? Why there is no 3v3 LDO, but when we powered it directly, disconnected from the system, we had 3v3, so we have input. Yeah, that's weird. So let's try to actually enable it somehow. I'm gonna use again the other supply. I have so many wires and crocodiles here. Okay, I'm gonna put the connector on the LDO line and I'm gonna enable this one. So this is enabled, but I don't have LDO. Why don't I have LDO in this configuration? Yeah, LDO I don't have. And 3v3 I don't have. That's insane. Yeah, so I'm providing the voltage. Didn't I connect the proper ground? I did. Yeah. So I have 19. This is insane. So when I come here, I should have... I have 3v3 now. And LDO. I have also the LDO. So I have all the lines. Right? If I take this probe out, I still have LDO. But I don't have the output. Yeah, now I have the output. Now no output. So how could we trick it? And why isn't this getting the enable? We could take it from the 5 volt enable. What do you say? Yeah, so the 5 volt enable, I said it's this one right here, which is 3v3. Okay, let's do that. Let's try that. I'm gonna disconnect the supply and we're actually gonna take, this is a very thick wire, I don't really like it, but maybe if we cut it here somehow, yeah, I should use a thinner one, but this is just for testing purposes. This is so thick and difficult to actually remove the insulation. It's a very good quality wire. Let's see if we can melt that insulation. I just need it here on the tip. And I should try to solder it right here. Now there's a huge mess. That's incredible. So please rate my soldering skills. which they apparently suck. Finally. Okay, now let's connect the power. Yes, I've connected the power to the board. We have 9 milliamps consumption. And let's see what about the power connector is not making a very good contact, but that's it, we're gonna have to live with it. So we have 3V3 and we have 3V3 LDO, we do. Yeah, and the 5V line is present also. So we have all the voltages required for this laptop to start. I'm not sure the 5V LDO, I didn't check, let's check this one. So the 5V LDO should be, if I look at the schematic, 5V pin 15, pin 15. So pin 15, 5, so this should be the 5V LDO here. Yeah, and we do have 5V LDO, good. So let's remove this one and let's put the laptop in the casing. Yeah, so we have the board back in the case. I don't have a round stick there. I've connected the supply, it's not making a very good contact. But let's try to press the power button. Yeah, well, it did something briefly, then it stopped. Okay, let me find some RAM memory for it. I'm gonna do one, and let's connect the power supply. $11 milliamps. I need to keep my finger on that. 9. Pressing the power button. See, it's trying to start. The fan spins, so it did spin 1 second and then it stopped, so we have some progress. Do it again. Again, I wanna see if the CPU is getting warm-ish. I'm not getting anything. I'm not getting anything on the CPU. Let me remove this. Try it again. Power on. Yeah. That's curious. Fan spin and it dies. Okay, Okay, I wonder what takes that small amount of power and then turns off. It stays on 30 milliamps, but nothing. Should I hold on more? I don't know. Let me disconnect this, connect the battery. Can it be one of those models? I don't know, I remember this was charging the battery, or wasn't it? Yeah, it does, see, 1.6 amps. Pressing the power button, goes to 0, fan spins, fan stopped, charging started. Yeah, so definitely we have a situation. Okay, I'm gonna go have a cigarette and think about my mistakes. Okay, so I'm going back to the drawing board and let's take care of these MOSFETs here. As you see, the MOSFETs that are from the CPU lines, there's a lot of corrosion here. Oh my god, so these actually don't have pads, nearly zero. That's interesting, I didn't notice that on the first try. Okay, let's try to fix them. So we're gonna start with this one. That seems a bit better. I need to put something under the board, maybe like that, to keep it a bit raised. And let's start with this first one here, and we're gonna remove them. We're gonna see how they look. We're gonna try to fix the pads and then add them back. Okay, so this is a double MOSFET. I'm gonna put it here, like that. Let's try to fix the soldering here. Okay, not bad. Let's see the back of the MOSFET. Lost it. Yeah, so this wasn't that bad, I could say. See if I can use this smaller iron. Yeah, so these three pads, I don't really care much about them because the whole thingy is together. So I think it's gonna be fine. This comes like this. way too much solder. I have some solder balls there. Can't remove that one. Okay, so that's gone. Let's move to this one here. I think I can put this back. There's actually no problem with it. Now let's see this one. This one is good too. Okay, and this one here. These are all double MOSFETs. Yeah, but this one is good too. We're not using flux because, as Sorin says, flux and rosin are expensive. Now I don't know what they did here. So this is something that has been, well, as I told you, this was probably attempted to be fixed at some point. We don't know what part was there, we don't know what part was here, but we can actually figure out probably from the schematic. I'm not sure, does that come to the first, to that pin up there? I think so. Yeah, I know it's not very clear for you, it's not for me either. Yeah, but I think that comes to the first pin. Yeah, definitely. Okay, let's look on the schematic. On the schematic, PUZ1, PUZ1, PUZ1. Yeah, this is the one. So pin 1 is there. Let's see what pin is that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Is it good? My math sucks, Jesus Christ. 53. So this is 53, 53, 40. So that should be 100 kilo ohms. So it's pin 40, right? Pin 40. 100 kilo ohms, so they put like a 0. And 0 straight to the 19 volt. So most probably this chip is crapping its pants. Let's check the resistance. Let's check the diode mode. So diode mode here 0.6. 0.6 is not bad. Okay, let's do the math again. Yeah, so it's pin 40. Pin 40 we should have a 100k resistor, and pin 39 again a 100k. Okay, let's go to resistance. Let's see this one here, 60k. 60k. Okay, and here we should have a 100k. Good. What about this one? That's 10 ohms. Good. .3. Yeah, these look good, so definitely sure they are okay. Zero 5k, 45k. Okay, so let me find soldered than 100k resistor there. But you know what I find weird? So these caps, see we have these large caps here. That's the entry power line for the CPU power, right? But I have nothing. I have nothing here, so I should have 19 volts. We should have the main power here. Why we don't have main? That's my biggest concern, because if I look on the schematic, right, so these are the caps, yeah, and this is the double MOSFET, right? So this is providing the APU core boost voltages, but I have nothing on this line. So this is 19 volts VBAT. It's coming through PLZ1 and PLZ2. PLZ1 and PLZ2. What are those? PLZ1 and PLZ2. PLZ4, PLA. So where is PLZ1 and PLZ2? PLB, a board view would have been great now. Where is this rail going? If I look on the other side, because it's a pretty hefty rail. Ah, lol. So here we should have, yeah, sorry. So here on the other side we should have here two inductors, PLZ1 and PLZ2. So these are the inductors here that transform our main V 19 volts into 90 volts VB CPU. So these two inductors here are completely gone. No more inductors here, so you can see yeah, it's all gone. So let's try. In theory I should put a wire, but in practice we should do better and put some inductors. Yeah, so that might be an issue and an explanation why our CPU is not getting power. Let me find some inductors. What? I'm gonna create my own inductor. Yeah. So this is the best inductor we can use. A properly calibrated wire. Okay. Don't tell anyone we did that. So let's give it a try now. I'm gonna power on the board. Okay, we have 9 milliamps, and let's try to prompt it to boot from here. No change. It's still taking 25 milliamps. Let's see if we at least have now 19 volts here. Yes, and we do. We do have 19 here. Nothing. And the gate. Nothing. Here we have 0.8. Yeah, before we didn't have anything here. Maybe it needs the RAM. Let me put the RAM back. Maybe it hates the life without RAM. Okay, let's try again. No change. So we still have a problem. Yeah, back on the drawing board. I was just poking around here. So this, I can't find anything wrong with this driver just yet. So I have the voltage. I have, for example, let me power on the board. Yeah, so the board is powered. We have 28 milliamps. Now if we look on the enable pin from this chip, so first of all we have 5S here, we have VCC, and the enable pin is this one we are on, that comes from the EC chip, right? Is the 37 pin, and it says here enable high. So if this is enabled, it should be higher than 2 volt. And if we go to the chip, yeah, this is the enable pin right here. You see it's 3.3. So we're fine with that. Yeah, I'm gonna turn off the power. I've measured all the lines, so all seems fine, but there's a resistor here that I didn't notice initially. See this one here? And this one seems damaged, well, at least this side of it. So According to the schematic, this should be around 100k, but let's move it. I'm not sure how important this is. We will have a look. Yeah, so this has no trace there and no trace below. This is gone, so let's see if we can actually grind this a bit. I am not exactly sure where it goes. But we're gonna add a bit of solder there. And I'm gonna have to find another 100k resistor. That's a big problem. Okay, so let's have a look on the schematic. Yes. So that resistor, where is it? Is this one here? Core switch 102k. I don't know what this is. Tone set CPU, no idea. So I'm gonna have to find another 100k resistor and try it out. It's gonna take me a while. Do we still have the old one? No, this is not it. Okay, right, so I have installed the 100k resistor right here. I had to extend this solder blob in this area, but all seems fine now. The 100k, the other one is here. Yeah, so let's make a test. So I'm gonna connect the supply. We still see 9 milliamps. I'm not sure if this should start by itself or no. Let's take it here so I can prompt it to boot. Oh my god, so we have a different behavior and the CPU is getting hot. Pooh. I'm turning it off. Oh man, I'm so excited. Let's go to the other side. Okay, so I have everything connected, mostly, yeah. Let's get the power supply. And I'm gonna press the power button in 3, 2, 1. My power supply is not making a good contact. It's off. Let's see now. 3, 2, 1. Fan is starting. I didn't put there's no heat pipe on the CPU. There's definitely some current draw. I see no picture for the moment. It did turn off. Okay, so let's put the heat pipe back. Oh, we made some progress. Yeah, and I'm gonna add some MX 6. I shouldn't use this good one while we're testing. And that's life, I don't have anything at hand. So let's see how this was set here, like this. Yeah, like this. I have no idea which of the screws. I don't know where I put these screws. Let's see with these ones. I think this is a bit too big, too long. Maybe it's this one. I just need one. I was missing the other one. So let's try again. Maybe connect also the battery. See if it behaves different on the battery. So we're on the battery now. I press the power button, we have a fan spin. Do we have... We've got picture, can't believe it. It did turn off for some reason. Maybe the battery is dead. So let me plug in the power. No bootable device. Yes. Yes. Oh man, so this was a very interesting repair. What can I say? Thank you very much for watching. Give me a like, subscribe if you didn't already, and we'll see you next time. Bye for now.